Ever wondered what happens in those few seconds when your FastAPI app starts up or when it shuts down? Most developers just write routes and move on, but there's a hidden lifecycle happening behind the scenes. Connections opening, resources loading, cleanup happening. And here's the thing. FastAPI gives you complete control over this. You can run code at startup, at shutdown, and handle it elegantly, but most tutorials never show you this part. So today I'm going to walk you through exactly how this works, from the basics to some really clever patterns I have discovered. Let me paint you a picture. You're building a FastAPI app, maybe it connects to the database, loads some config files, initializes a Redis cache, whatever. Now you could initialize all of that inside your route handlers. Every single request connects to the database fresh, loads the config again, but that's obviously slow and wasteful. Or you could set up everything up once when the app starts. That makes way more sense, right? Connect to the database once, load your ML model once, set up your cache connection once. But here's the interesting part. What happens when you need to restart your app? Deploy a new version, scale down, container. You want those connections to close probably. Resources to clean up gracefully. That's where lifespan events come in. They give you these perfect hooks to say, hey, run this when starting up and run this when shutting down. Clean, elegant, and no leaks. And the cool thing, once you understand the pattern, you can do some really clever stuff with it, like handling database migrations, warming up caches, and graceful shutdowns. FastAPI lifespan events let you run code at exactly 2 moments, right before your app starts, accepting requests, and right after it stops. That's it. Simple concept, massive impact. Here's why this matters. Let's say you have a machine learning model, loading it takes 30 seconds. You have 3 options. Option 1, load it on every single request. Result, 30 seconds per request. It's a disaster. The second option, load at module import. So the problem still is it's loading during testing, development, and displays everything, and you certainly don't want to load the full model for testing. The third option is load once at startup with the lifespan events. Results, 30 seconds just takes once at the beginning of the startup, and then you can use the model for all following requests. Lifespan events are for everything that's expensive to create, reusable across requests. Database pools, ML models, cache connections, HTTP clients, load once, use everywhere. So let's jump into the code. Here I can show you the first example. We import the context lib with the async context manager, and we import our FastAPI application client. We have a shared resource dictionary, which we can use for shared logic or resources we need to share between the startup, the closing, or across endpoints. Now we define our async lifespan function with the app as a variable, and now comes the important part. We have logic that is handled before yielding, and we have logic that is handled after yielding. Everything that comes before yield will be happening before the startup, or on how you call it, startup application, and everything on after yielding will be handled on the shutdown, so you can use it to close or clear resources. We have the FastAPI app initialization, and we pass in the lifespan function. So this will be handled now automatically. We have a simple endpoint, which we're not going to need to use, but this would use the shared resources to increase the counter for the amount of the requests we have done to this endpoint. So I will start up this example. Now you can see we see the print of starting up. This is this print. This is happening on the startup, and we can see the startup is complete. And now if I close this with Control-C, you can see shutting down, total requests handled. That would be this print, and we can see the shutting down print. Everything after the yield is happening on the shutdown. Now let's jump into a different example. This time for database management. We have a simulated database class, and we initialize the database. You can see we have a connect function, a disconnect function, and a query function. All of that takes some time. The connect takes some time. The disconnect takes some time. Like in real world, you would use the real database client. We initialize the database globally, and then we have again our lifespan function with the async context manager. And we can see we have before the startup or on startup, we connect to our database, and everything after the yield is happening on the shutdown, and on the shutdown we would disconnect from our database. This would make sure that we initialize or disconnect from all our database connections on either startup or shutdown, and don't have open database connections even after closing the shutting down the application. Here I would have some sample queries which we're not gonna need to use because this is just for the example of the starting and the shutdown. Okay, so now let's start this example. We can see application startup, this is this call, and we can see the db connect call, connecting to database connected. This is our simulated database connection. You can see the prints. Now, if I close this again, we can see shutting down, and our lifespan event on shutdown is called application shutdown, disconnecting from database, and database disconnected. You can see the disconnect, this is the print calls, and we can see the application shutdown right here. So this is another example. Now I have a third example as well for machine learning models. This would follow the same logic. I'm not going to start this one, but I can show you how you would use that. You have the same, like you can understand this pattern right now, right? We can load the model. We load our ML model at the startup. We can print what model we have available. This is just for logging to see something happening. And we have the yield again. Everything after that is going to be happening on shutdown. We have the unloading models and clearing our ML models. And again, we pass the lifespan event to our FastAPI application. Same logic, everything the same pattern, just this time for machine learning models. And here you would use a real model loading and predicting. This is just some example code, which I will upload for you to check out and play around with. Now let's jump in how old tutorials show the startup. Like you can see, this is how it was before the version which updated the lifespan events. Before you would use, we have used the app, and on event you would use the startup event. You can already see this is deprecated, which you shouldn't use. Some old applications use that, but you need to use from now on, or you should use the new pattern. You can see it's the same logic, but happening in the function with the startup decorator. And we also have the shutdown event. It's the same events, just old and deprecated. So this is the comparison to the new pattern. This is the old one, and this is the new one I already showed in the previous examples, using the async context manager, using the one single lifespan function, and everything before the yield is on startup, and everything after the yield is happening on shutdown. So here's your challenge for today. Go to your FastAPI project right now, find something you are loading on every request, move it to a lifespan event, or update your FastAPI version to something newer and use the new lifespan pattern. Time how much faster your app becomes, then comment below and tell me your results. And if this saved you hours of debugging or sped up your application, hit that like button, subscribe for more FastAPI content or other web development content, and I will upload this code to GitHub for you to check out. So thanks for watching, and if you're on the search for a FastAPI application template to speed up your development of a software as a service application using FastAPI as the backend, I can recommend my template, which you can find on FastLaunchAPI.dev. And it is featuring FastAPI, PostgreSQL, Redis, Docker, Stripe, Celery, and Alembic, and using SQL Alchemy as the ORM. So this can speed up your development if you spin up a new application from scratch, and I will see you on the next video.